This next example, this next type of problem we're going to look at, we're going to see what happens when we graph a relation and its inverse. So we are going to graph the relation y equals negative 2x squared plus 3 and its inverse. Now I'm going to use my handy dandy little coordinate plane stamp here. Worked pretty well, not perfect. To graph right here on my paper. Okay, now in order to start graphing this, y equals negative 2x squared plus 3. And remember a few things. First of all, this is a parabola. And if I think of my transformations, I know it's reflected. We have a vertical stretch here, and I know my parabola was translated up 3. We haven't translated left or right at all. So knowing that, I know my vertex is going to happen right here at 0, 3. And then I could plug some other points in, knowing that this is my axis of symmetry. So if I plug 1 in, 1 squared is 1 times negative 2 plus 3, I get 1. Same on the other side of my axis of symmetry. And if I plug 2 in, 2 squared is 4 times negative 2 is negative 8 plus 3 is negative 5. 2, negative 5. It's right over here. And same on the other side of my axis of symmetry. So my original here function looks like this. Okay, and I know this is a function because each x value has only one y value, and also we know that vertical line test back from Algebra 1. We can draw a vertical line anywhere and it only passes once, so we have a function. All right, so to draw my inverse, remember that inverse is the x and the y switch. So the easiest way to graph my inverse, if I know my original, is to switch my x and my y values around. So this point here was 0, 3. The point 3, 0 is on my inverse. 3, 0. Okay. This point was 1, 1. If I switch my x and my y around, it stays 1, 1. So this is on my inverse as well. My point right here was negative 1, 1. Switch my x and my y value around, I get 1, negative 1. Down here I had 2, negative 5. Switch the x and the y around, I get negative 5, 2. And then over here, this point was negative 2, negative 5. If I switch my x value, switch my x and my y, I get negative 5, negative 2. So these green points now are the points of my inverse. Twist my paper to the side for a second. Okay, so you can see this green is my inverse. Okay, I'm going to make a note over here that the inverse, this inverse is not a function. Okay, so my inverse is not a function because if I look at the green, if I draw a vertical line, I'm crossing my graph more than once. And that kind of leads us to something that is called the horizontal line test. Okay. The horizontal line test tells us that if you can draw a horizontal line through the original relation, only crossing once, the inverse is a function. Okay, so the inverse is only going to be a function if you look at the original, if the orange here, if we can draw a horizontal line and only hit our graph once. Okay, similar to the vertical line test, that works. We're just looking at the original. And if you look at our original again here, the orange, if we draw a horizontal line, we're crossing more than once. That tells us that our inverse is not going to be a function.